Hello everyone, Eisenberg here. Today we're going to look at why a triangle amongst all the shapes is the strongest one. Well, let's analyze it. Let me pick my pen and let's start. Imagine you put heavy objects on triangle. What will happen is that the force will be translated along the lines like this. Then, if we were to separate this into its components, I mean x component and y component, also this one, these components will take the triangle down, and if there is a ground under it, it will cause almost nothing. I mean, it doesn't do too much, like in other figures I will show in a minute. And also sideways, well, let me put these a little bit aside. And if the triangle tries to go sideways, its base won't let this happen. When it comes to y-axis, the forces on the y-axis, basically triangle's base won't let it happen. I mean, in order to go sideways, the bonds of this triangle, or the material what it's made of, the bonds should be broken in order to make the triangle apart, tear the triangle apart. So unless these bonds are weak, this is not gonna happen. So we kind of analyze the triangle. Let us see the other objects and why they are disqualified from. Well, when it comes to square, as soon as you put an object, well, it will separate along the lines. There is, I would say, not so much, there is nothing wrong with it. It will translate this force to the ground. However, there is a risk of square going sideways. I mean, if we were to apply force in this side, there's a possibility that square will go sideways, which is undesirable. And this makes square disqualified. So we're done with it, basically. Let's have a look at circle or torus, whatever we call, or sphere. But we apply force. It will separate along the lines. It's more likely to deform in x-axis. What I mean is that it has more inclination towards scaling on the z-axis. What does it mean? That basically means that it will be crushed. The size of it will decrease because the force isn't quietly separated in a desirable way. But in square, but in triangle, that's not the case. You see, the angle is too conveniently placed so that this is not going to happen. I mean, if you try to change the angle of triangle, it may happen, but the strongest figure amongst triangles is equilateral. I mean, this length of 3 lines is equal. So you may also ask, or is there any possibility that triangle will go sideways? Well, not actually. It is more prone to rotate rather than go sideways. Triangle is much more stronger than you might think. So back to circle. What makes circle or sphere distinct is that if you were to put liquid in it, the amount of pressure on all the sides will be equal, making it much more difficult to break the circle apart. In order to do that, the liquid inside the barrel or spherical chamber should break the bonds of the material in order to break through it. You know what I mean? Like, all of them should be stretched like that. Less likely to happen. But when it comes to triangle, if you put liquid inside it, it is obvious that these three parts will take much less pressure than these parts. These parts looks naked compared to these thinner parts. Okay, one more thing. So when it comes to hexagon, which are basically used in beehives, hexagon are the most efficient figure amongst all. It doesn't let any space to be left as a waste. And in terms of force, I mean in terms of stress or strong figure, it will separate the forces like that, after which if we like separate the forces in two directions, the down force will go like that. There's nothing wrong with it. But when it comes to these forces, these ones will make hexagon vulnerable, because there's nothing to interfere. I mean, there's nothing to neutralize this force. I hope I can explain. Well, there it is. And one more thing, you may say that you didn't rotate square. You didn't rotate square. What will happen? Basically, we applied force, it will separate like that, after which it will go like that. I mean, they will be separated like that. The down ones are not much of a problem, but when it comes to these forces, just like in the hexagon, there's nothing to neutralize these forces, and will cause square to move. Well, sideways forces will make square like that. You see, it is deforming, which is again undesirable. Let's turn this bad boy upside down and let's apply force. What will happen? This is not gonna separate two sides. In order to solve this problem, second triangle is put beside this. Let me show you. Well, the triangles are put like that, so whenever there's a force applied, instead of separating two sides, which is not going to happen, it will force these two parts down. It will force them to go down. But the second triangle not gonna let this happen. Okay, these triangles, I mean these two, will counteract with the main force, which will again make the structure much more stable and strong. Well, hopefully I will answer some of your questions about triangle, like what's the strongest shapes amidst all. Anyway,